Today I'm going to refactor the code of a game submitted by one of you. Yep, time to roast some code. Before I start, I want to give you something. It's a free guide available at ArjanCodes.com/design guide that contains the steps that I take whenever I design a new piece of software. I hope this helps you in taking those steps in your design faster and avoid some of the mistakes that I made in the past. So get your copy for free at ArjanCodes.com/design guide. I've also put the link in the description of this video. Thanks to Asif for supplying the code for this one. The game I'm going to be looking at today is Rock-Paper-Scissors-Lizard-Spock. You probably know this game if you watch The Big Bang Theory. It's based on the classic rock-paper-scissors game, but takes it up 2 notches. There are also other varieties of this game, by the way, like Rock, just Rock, or also known as a fist fight, or there's also Rock, Paper, Scissors, Chuck Norris, where the strategy is basically to always pick Chuck Norris, unless you're playing against Chuck Norris. But that won't happen, because Chuck Norris doesn't play games. Can we please just skip to the code now? Before I start refactoring this game, let's first diagnose the code. This is actually a really important part of refactoring that a lot of people forget. That before you start changing things in the code, it's important to actually understand what the problem is. So what I'm going to do is go through each of these files and then talk about the problems that I see, and then after that we can start refactoring it. So I'm going to start here with the main file, which uses a game class that basically does the job of running the game. And the only thing that's happening in the main function here is we're reading a username, we create a game where we pass the username, and then we call play. So in essence, this file is fine. It's pretty short. Most of the logic and everything related to the game is in the game class. So that's actually where more of the interesting things happen. So here we have the game class. It has a couple of imports, like it imports a scoreboard, which maintains the number of points for each player. It imports rules, and it imports an entity. What an entity is, I'll show you in a minute. A game class, it has an initializer. When you initialize this prints the rules. It creates a scoreboard. It sets some instance variables like the maximum number of rounds, the rules, the name of the user, and things like that. And it registers the player in the scoreboard. This is actually nice that the scoreboard has a register player mechanism. That way, the scoreboard doesn't need to know anything about particular players, but it gets that information when it needs it. So that's pretty good. Then, in the game class, we have a couple of methods for displaying stuff. Like here, we're displaying the choices that the user can select in each round. It asks for user input. When you're talking about entities here, what's actually meant is the different things, the different objects in the game, like rock, paper, scissors, etc., etc. So get user input basically lets the user choose which of the things they want. Then we have CPU input. So in this game, you're playing against the CPU, and the CPU simply selects a random entity. So that's what you see is happening here. Then we have a couple of other display methods, display the current round, which takes the user entity and the CPU entity, and then it prints the information. We have display tie, that prints the tie message. Then we have the display round winner, that displays the information about the player that won this round. And there's also a message. And then we have the basic game logic. So there's do turn that basically reads the entities that the user and the CPU select. Then it's going to display that information. And then depending on who the winner is, it's going to display something different. Then there's a static method that gets the username. So that's what's being run in the main file before you actually start the game. And then there's a play method that basically goes through each of the round, does the turn, and then displays the scores. So that's the game class. Then here we have an enum for representing the different kinds of entities in the game, rock, paper, scissors, etc. So nice that it's an enum. We have a file with the rules. It contains a single class rules that basically describes the relationships between each of the entity types. So paper wins over rock, paper wins over Spock, rock wins over lizard, etc., etc., with all the possible combinations. And it also has a get winner method that for any 2 given entities can determine who the winner is. And it's also going to send back a message like Spock smashes scissor, for example. Finally, we have the scoreboard class. The scoreboard class is not much more than a dictionary that maps player names to points. You can register a player in the dictionary, and it has a display scores method to display the scoreboard. Let's run this game and see what happens. So I'm going to enter my name. And now let's play Rock, Paper, Scissors, Spock, and Lizard. I'm going to select Spock, so that's 4. So Spock wins the round as Spock, Paper, as Rock. That's great. I'm ahead, so let's continue. Now the CPU, 1. Let me choose something else. Scissor. It's not going so well. Okay, Spock again. Ah, damn it. Okay, the CPU won. CPU always wins for some reason. So let's do an analysis now of the code. And I'm going to start with the game class. Now, the first thing that I noticed is that the game initializer, the class initializer, it contains lots of things. For example, it displays the rules, it reads some input, it creates all kinds of objects. So it registers the players in the scoreboard, and in my opinion, this is too much. My general rule is that when I create a class, when I write a class initializer, that the code in the initializer should be mainly concerned with initialization of that particular class. So, for example, something like printing the rules, I don't think that should be part of the initializer. That should be a separate method, so you can call it separately. And also what I generally avoid is that in the initializer of a certain class that I create instances of other classes. Like here, I'm creating a scoreboard and I'm creating a rules instance. I tend to go more for dependency injection. So I would actually change the class to let scoreboard be injected into the initializer so that that's where you establish the dependency. And then also you have a bit more control over how the scoreboard is created. And you can also write tests a bit easier. Another thing is that game has a couple of methods here to display things or to read things from the user. And it has methods that actually do the game logic. What I like about this is that you try to separate the logic from the printing stuff and the reading stuff from the input, which is great. If you look at do turn, for example, well, there are no direct calls to print here. So basically the logic for doing a turn, you could in principle let that be used with, let's say, a GUI or something, and then you just have to change these methods. So you would have to make a subclass of game in order to do that. But unfortunately, you didn't go all the way. Because, for example, here in the initializer, well, you're still printing stuff. And in the scoreboard actually also has a display scores that also prints the scoreboard. So if you want to truly separate the way that your program interacts with the user, whether that's via the console or via user interface or an app on your phone or whatever, you need to make sure that that code can be easily extracted from the main code. And currently that's hard because if, let's say, we wanted to change this game to use a GUI, well, we'd have to go into the game class, make a subclass, but then this would still happen. So we'd have to refactor this to solve that. But also now we have to go into the scoreboard and make sure that when we display the scores, it's actually going to print something, but it's going to do something else. So we need a better mechanism to separate the printing part from the rest of the game. So the entity enum, you use auto to assign an integer value to rock, paper, scissors, etc., etc. So the fact that you're using an enum to represent entities is nice, but what I don't like so much is that you're relying very much on the fact that these are integers in your game class. So for example, here you're converting the input that the user provides to an int, and then you're directly using that to access the elements in the list of entities. I would set this up a bit differently to separate the representation that you're using from the order of the elements in the representation. Now, if we go to the rules class, there's also a couple of things here that I think could be improved. The thing is that rules is actually a class variable, and we have the getWinner. That's a regular method of a class. So getWinner then accesses the rules, which is a class level variable. So I think that's kind of confusing. I would either define the rules as a regular instance method because you're also creating an instance of the rules class, or I would actually remove the rules class altogether. Because why do we have a rules class here? We could also have rules as a constant and then add a function that uses that constant to determine which of the two entities is the winner. If you look at the rules structure itself, you see that it contains tuples, combinations of entities, and that maps to a winner and a message. And you did that for basically every possible combination there is. There's duplication here in that the winner is always the first element in the tuple, but we also have it here as a result, so I don't think that's necessary. Another area where there's duplication is in the message. The message contains the string values of each of these entities, And that means it's going to be hard, for example, if you want to translate this game to another language. So in rules, there's duplication, and I think we can shorten that. And that would be nice, because suppose we want to add extra entities to this game, like Chuck Norris, for example, then adding those rules is going to be a lot of work. And if we remove that duplication, that's going to be a lot simpler. So about the scoreboard, it uses a dictionary, but actually you don't need to import it from typing anymore if you're on a recent version of Python. So we could actually remove that and simplify that a bit. And also, I don't see the need to use default dicts. I would just use the braces to initialize the dictionary. I think it's a bit simpler. And of course, the fact that I already mentioned that scoreboard contains a display scores method that prints stuff to the screen. I think we should avoid that. Finally, in the game class, there's a violation of the law of the meter. The law of the meter states that a unit of code, that can be a class, or a method, or a function, should have only limited knowledge of other units of code. It basically helps a lot with decreasing coupling if you take that into account. And the issue is that if you look at the doTurn method, there's a violation here when the game class uses the scoreboard class. Here you see that there is the scoreboard class. It accesses the point for a specific user and adds 1. That introduces coupling, because game now needs to know that scoreboard has a points dictionary, and it's going to access that dictionary directly. And that's generally a bad idea. The consequence is that even though you separated game stuff and scoreboard stuff, if you need to change anything to the points dictionary in the scoreboard class, then probably you're also going to need to change game, because there's this coupling happening. So I'm going to fix that when I refactor this code. Finally, I think we can do some improvements in the naming, like get username. It's a bit unclear what that means. In general, what is a user? User is a very generic term. Since it's a game, I would prefer to call it a player. I think that makes a little more sense. And related to that, I think we should also rename some variables like user entity to player entity to clarify that this is somebody who plays the game and not just a generic user. So that's an overview of the code and my analysis of this code. So what I'm going to do in this part of the refactoring is remove the printing code from the game to better separate that and give us the possibility to use the game logic with other kinds of interfaces in a cleaner way. And the way I'm going to do that is that I'm going to group all the printing stuff and reading input stuff into a class. Let's call that UI. And we can create a protocol for that. And then game doesn't need to know anything about printing stuff or reading stuff. It simply calls the methods from the UI. So I'm going to start by creating a UI protocol. So the UI class is going to define all the methods needed for displaying things and for reading input from the player. You could separate that into 2 different classes if you wanted to make it even cleaner. But for simplicity, I'm sticking with a single class in this example. So there's a couple of methods that we are going to need. So if you look at the game class, we can actually take a look at the methods that are in there. So we have a method for, this is called get user input, and we have get CPU input. But what these methods actually do is let a player pick a particular entity. So what I am going to do is rename those methods here, and I'm going to call them pick player entity. And this is going to return an entity that we can automatically import. And for now, we're going to raise a not implemented error, because I'm not going to implement it in this protocol class. Similarly, we're going to have a pick CPU entity. That's also going to return an entity, and we're not implementing it here. There we go. So what I'm also going to fix immediately is that we want a method for displaying the rules, which are now in the game initializer. So let's also add a method here, display rules. This is not going to return anything. So then we have a method in the game class to display the current round, but it also relies on the name of the user and the CPU. So what I'm going to do in the protocol class is I'm going to define the display current round. And then we need to pass the player name, the CPU name, which is a string, the player entity. So this is the entity that the player selected, the CPU entity, and this is not going to return anything, and it's going to raise a not implemented error as well. So this is going to display the current round information. Then we can have a method for displaying that there is a tie. And if we look back in the game class, we're also going to need a display round winner. Let me just copy this over. There we go. So that has a winner name, a winner entity, and a message. And that's also going to raise a not implemented error. There we go. And finally, what I'd like to do is separate the printing from the scoreboard as well. So what I'd like to do here in this class is actually add a display scores method. And what is that going to need? Let's take a look at the scoreboard. So actually, this is going to need the points. So one thing we could do is pass the scoreboard to the display scores method so that it can extract the points from the scoreboard. It has some disadvantages because then the UI needs to know what a scoreboard is. We can also simplify this and say that in order to display the scores, we're going to need simply a dictionary from a string, a player name, to the number of points. And let's call that scores. There we go. No return type. And raise not implemented error. So basically these are all the methods we need for reading information and printing that to the screen. And now what we can do is provide an object that follows the UI protocol, provide that to games, and then game uses that object to do the printing and the input reading. So let's create a command line interface implementation of this UI. Let's call that CLI. And this is going to implement the UI protocol. So to make that simple, I'm just going to copy all this code over here. And we're not creating a UI, but we're creating a CLI. And this is going to have all these different methods here that we're going to copy over from the game class. So let's go back to the game class. Display tie, that's actually pretty simple. So I can copy this line and then go into my CLI class. And then we have it here. And let's paste it and delete the not implemented error. This also doesn't need to have an F. It's not an F string, so that's not needed. And we can do this for the other methods as well. So we have display the rules, which is in the game class. Let's go up and the rules are here. So I'm going to copy these lines right here to my command line interface. And that's going to be here, like so. Let's indent this correctly and add a line here as well. So that's going to display the rules. This will also read some input. You could separate that more if you wanted to. I'm going to leave it as it is. So that's already something. Let's first do a bit of scaffolding before I complete this CLI class. So go into the game class. So game is now going to require a object that follows the UI protocol. So we're going to pass it an object of type UI. We can import that automatically and we will store that here, like so. And now we can start removing some of these methods in the game class. Like, for example, we had the display tie method. That's right here. So I'll remove this. And where is that display tie? And we're calling that in the do turn. So now what we can do is instead of calling display tie, we can call self.ui. Display tie. And the other thing we added was display rules. So I can go in the game class. Now I would like to remove this from the game initializer. So what we can do instead is, if we scroll down, there is also a play method here. So I think it makes more sense to display the rules when we start playing the game. So let's add here a self.ui.display rules, like so. And now I can scroll up and I can remove the print statements here. And that already simplifies the initializer a lot. So let's copy over a couple of other methods as well. So here we have the display entities to select. So I think this is really more of an internal method actually, because displaying the entities to select, that's going to be different for the different kinds of user interfaces. And you also see that in the game class, the display entities to select, that's actually only used in get user input, if I'm not wrong. Yeah, so that's the only place where it's being used. So what we can do is basically take this code right here, Let me copy that, and I'm going to my CLI. That's going to be pick player entity. And let's paste that right here. And here we see we rely on self.entities. That's basically, if you look at the game class, the entity enum. So what we can also do here is simply replace this by entity. And I'm going to do a couple of changes here later as well. And the same thing here. So we can write entity right here. And now the only thing we need to provide is this function. That's basically going to turn the entity enum into a printed list. So you have the choice that you can select. What I'm going to do is I'm simply going to copy this method right here. And I'm not going to add it to the class because it doesn't need to be exposed to the outside. So I'm just going to put it here like so. And I'm going to put an underscore in front of this. And then let's change this so that this actually doesn't print this, but that it actually returns a string. I think that makes a lot more sense. And then let's also call this something like entities string. So it helps us turn the entities into a string to display as the choices. So that means that this thing is actually what it's going to return, like so. And then I think the print call here to select a particular entity, we should put that here in the pick player entity method. I think that makes more sense. And then what this is going to be is select entities string. And that's going to return the string for us. Let's delete this because that's no longer needed. And now we have our pick player entity method. And in game class, we can now remove the display entities to select because that's not needed. We can remove get user input. And let's see where we're actually using this. So that's here in 2 places we seem to be using it. Oh no, that's another method name. So let me change this to self.ui.pickPlayerEntity, like so. And we can do the same thing for the CPU entity. So let me scroll up. So this is the CPU entity code. Go to my command line interface, pick the CPU entity, put the code right here. So we're going to need random. Protocol is not needed here. And let's also use here the entity type instead of this self.entities thing, like so. And now we go back into the game class. This method we can delete. And here in the doTurn, we're going to pick the CPU entity like so. So now there's only a couple of more things here. There's the display current round and there's the round winner. And these are pretty simple to copy over. So let me copy this code, display current round. We have that as well in the CLI class. That's here. Let's paste that code here. And we just need to fix some of the variable names. So this is not self.user, but it's the player name. This is player entity.name. This is not self.cpu, but CPU name. And this CPU entity name is correct. So that's our display current round. And we can do the same thing for the round winner. So that's also a single print statement. Let's copy that and let's go to the display round method here. And let's paste that, remove this. And I think that's the only thing we need to do here. Yeah, so that's display round winner. And now we can finally clean up the rest of the game class. So let's delete this method. Let's delete this method. And now we just have to fix the method call. So this is not self.displayCurrentRound, but this is self.ui.displayCurrentRound. And we have self.ui.roundWinner. Same thing here. So now the only thing that's still in here is get username. And there's actually, honestly, in my opinion, not really a particular reason to make this one static and the others not. So I would actually suggest to also move this method and make it a normal method and make it part of the UI protocol. So in the UI protocol, let's simply add a method read player name. And that's going to return a string. And of course, also not implemented in the protocol. And let's copy this line to the command line interface. So that's going to be here, paste it. And we're going to copy the player name reading that's right here. Let's copy that to the command line interface. There we go. And actually input.strip already returns a string, so there's no need to convert this into a string. So we can remove this like so. So I have read player name as well. And now what we can do is remove this static method here, like so. And what's left in the game class is actually, this import can be deleted as well. What's left is the game initializer that does mainly initializing now. We're going to clean this up more soon. We have a do turn and we have a play method. So that's already getting pretty simple. There's a couple of things we actually don't need anymore because this entities thing, I think that's not used anymore in the game class. So we can actually delete this. And we're going to simplify a couple of other things as well, but I'll do that in part 2. The only thing that we need to do still is in the main file, well, game now needs not only a username, it needs a UI instance. So what we're going to do here is patch things up. So first, I'm going to need a user interface. And of course, I'm going to use my command line interface. So I'm going to create an instance of my command line interface, and then I'm going to pass it to game. And the nice thing is we can now read the player name using our command line interface before we create the game. So what we can do here is CLI read player name. And that's going to give us the player name. Let's also rename this to player name like so. And now we pass that to the game and we call game.play. So that's pretty nice. Actually, this comment doesn't really add much. So let's also remove that. And let me close these files and let's now run the code and see whether this still works. So I'm going to enter my name, Arjan, rock, paper, scissors. Let's see which one do we want. So there is a type error. Let's see, that's the entities string. And let's see what we did wrong here. Yeah, so there's a self, which is of course no longer needed. Let's run this one more time. Press enter, still get an error. And here, of course, we also should change this to use entity directly. Let's try this one more time. Okay, so I'm going to pick a rock. Now we also get an error. Display current round is missing some things. Of course, if you look at the display current round, that's also going to need the player name and the CPU name. So let's add them here. That's called self.user, self.cpu. I'm going to rename these later on. And let's try this one more time. And as you can see, this seems to work correctly. And of course, again, the CPU one. So that's the first part of this refactoring, where the main thing that we achieved was separating the user interface things more cleanly from the game class. In the next part of this refactoring, I'm going to simplify the rules a lot, update the game logic to use those new rules and make things overall a bit simpler and easier to manage. So I hope you liked this first part. If you did, give this video a like. Consider subscribing if you want to learn more about software development and software design. And let me know in the comments what you think about the refactoring so far. Thanks for watching, take care, and see you next week.